Welcome to This Explainer. Okay, let's just dive right in and explore the massive mechanism we call our solar system. We look up at the sky every single night, but actually grasping the sheer scale and the clockwork-like precision of our cosmic neighborhood, it is totally mind-bending. Today, we're going to break down exactly how the system operates, how it's built, and the hidden forces that keep the whole shebang in perfect balance. 99.8%. Just kind of let that number sink in for a second. What do you think that staggering percentage could possibly represent in our vast solar system? Well, if you guessed the sun, you hit the nail on the head. 99.8% is the sun's share of the solar system's total mass. Literally everything else, Earth, all the other planets, moons, asteroids, comets, all of it combined makes up just 0.2%. It's wild. And because the sun is hoarding almost all of this mass, its immense gravitational pull is the central engine governing absolutely everything around us. Section 1. The sun's gravitational grip. So this immense gravitational grip, combined with planetary inertia, does more than just keep things tethered. It actually dictates how fast planets move. The rule is simple. The closer a planet is to the sun, the faster it has to travel along its elliptical orbit. It acts exactly like the unseen gears of a giant cosmic clock. The inner gears are just zipping around, while the ones way out on the edge take a much longer, much slower path to complete their journey.
Moving on to Section 2, Inner and Outer Planets. You can see here how this gravitational system divides our 8 major planets into 2 really distinct squads based on their distance from the star. Right up close, we have the inner, rocky planets, Mercury, Venus, Earth, and Mars. These guys are tightly packed and travel much faster. But once you cross past Mars, the environment changes drastically. We hit the outer, giant planets, Jupiter, Saturn, Uranus, and Neptune. They are massive gas giants taking these super wide, slow laps around the sun.
Which brings us to Section 3, moons, asteroids, and comets. Because, hey, planets aren't the whole story, right? The system is totally packed with highly dynamic smaller bodies. You've got moons, which bypass the sun to orbit the planets themselves. Then there are asteroids, basically rocky fragments, mostly clustered in that famous belt sitting right between Mars and Jupiter. And finally, we have comets, these icy wanderers that originate from the very, very edges of our system, in the Kuiper Belt and the distant Oort cloud. Now, the Oort cloud is this incredibly distant, freezing region. But here's the really cool part. When one of these icy comets gets knocked out of orbit and plunges inward toward the inner solar system, it hits the intense heat of the sun. That heat blasts the frozen surface, causing it to rapidly release gas and dust. And that reaction? That is exactly what creates those iconic, beautiful, glowing tails we see trailing behind them in the night sky. All right, Section 4, Birth of the System. To really grasp how this complex clockwork was built, we got to rewind about 4.6 billion years to the solar nebula. Think of this as the ultimate cosmic assembly line for everything we've just talked about. Originally, there were no planets, no moons. It was nothing more than a giant, formless cloud of gas and dust, just floating in space. Let's walk through this epic cosmic origin story and see how gravity literally forged our reality. Step 1, you have that giant cloud of gas and dust. Step 2, gravity kicks into overdrive, causing the whole mass to collapse inward. Step 3, that collapse creates insane pressure and heat right in the dead center until, boom, the sun ignites. And step 4, all the remaining material swirling around gradually clumps together over time to form the planets and other celestial bodies. And finally, Section 5, our galactic journey. If we zoom all the way out from our local mechanics, you realize that absolutely nothing in space is sitting still. It's literally a system of orbits within orbits. The moon orbits the Earth, the planets orbit the sun. But guess what? The sun itself isn't static. Our entire solar system is continuously orbiting the supermassive center of the Milky Way galaxy. We're all on this massive, constant journey through deep space together. 230 million. That's the number of years it takes for our solar system to complete just one single galactic orbit around the Milky Way. Just to put that staggering timeline into perspective for a second, the last time our solar system was in this exact spot in the galaxy, dinosaurs were just beginning to roam the Earth. Which leaves us with a final, kind of mind-blowing question. If it takes 230 million years to complete one lap, where in the galaxy and in what state of evolution or exploration will humanity be when we complete our next orbit? It's a pretty profound thought, right? Really puts our entire cosmic mechanism and our little place inside of it into a completely new perspective.